In this segment, we're going to talk about how to clean the system. Now, the biggest issue that most people are going to face with any electrochlorination system is scale formation in the electrolytic cell or in the discharge fittings. This is caused by calcium carbonate scale forming in the system. It's a very good breeding ground for calcium carbonate scale. And carbonate scale comes from two sources. One is salt. So if you're using poor quality salt, road salt, there's some pretty nasty salts, but the system can use them. And the other is the water. So if you're using well water, for instance, that is hard, it'll have scale or calcium carbonate in it. And when you mix the brine with salt and hard water, you're going to have calcium carbonate that's going to get in the cell, and it's going to plate out in the cell and accumulate in the cell. And then it ultimately will plug the discharge ports on the cell. The anode is the low pH, so it'll dissolve off the calcium carbonate scale and keep the internals in the cell from damaging the cell. Now, there is no electrolysis going on in the discharge tubing or the fitting, so scale will form in these fittings if there is carbonate scale in the salt or the water. Now, you can avoid this altogether by using soft water from a water softener, an ion exchange softener that removes the calcium hardness from the water, and using food grade salt. So if you're in the proper setting or the right setting where you can get those, that type of salt and that type of water, then you'll have almost no problem with this system in terms of scale formation. Ideally, you clean this system before the alarm flashes, and the alarm is going to flash red, green, red. Gotten to the point that scale has built up so that the flow is restricted. When the flow is restricted in the cell, it gets slow, and there's still energy going into the cell so that the disinfectant gets hot. And there's a temperature device, thermal well we call it, to measure the discharge temperature of the water coming out. And when that gets to a point that is uncomfortable, then the system shuts down and alarms with a red, green, red flash. And we've removed this cell from the system. So there's some features that we've included in the design of the cell to protect it from damage in the event that it forms scale. So we have a rupture disc we'll talk about that ruptures if the pressure gets too high in the cell from scale forming. So we have taken this cell out, we have removed the hardware, something you can do in the field, and so we'll show you the what scale looks like in the cell. This is scale formation, typically on the outlet of the cell. This is the mating part that has scale in it as well. So scale has formed pretty aggressively and blocked the discharge ports. So now what we're going to do is put the cell back together and go through the acid washing procedure, which uses just common vinegar typically to get rid of this scale and allow the system to operate normally again. What may happen is that the rupture disc that's here on the end of this will fail. And I'm going to show you an example of a failed rupture disc. You can see that the Teflon disc in here has ruptured because of too much pressure in the system. In a rupture disc that hasn't failed, the rupture disc is clean. You can see it here. The rupture disc that's off on the side. We have the brine filter that's in the brine tank here. And we have the oxidant fill line that goes into the brine, to the chlorine storage tank. Now it's important to note that this fitting on the end of the oxidant line needs to be removed before you do this process. And the reason for that is that this fitting has a smaller hole in it, and we don't want scale coming out of this tube to be blocked up in this fitting. So remove this fitting before we go to the next step. And the next step is to take some vinegar. Common white vinegar is good. And you put the brine suction filter in the vinegar, as well as the tubing that goes into the oxidant line. Also note, be very careful, there's some ferrule fittings on this tube, and you do not want to lose those ferrule fittings. So be careful when you're removing the fitting or handling this, that you don't lose the ferrules that are on the end of the tube. But you put the tube fitting in the tank as well. So now you have a closed loop system with the vinegar. And what we're going to do now is turn on and operate the system for 30 seconds twice. And that will ensure that the lines are full of vinegar, that they've circulated through, that the cell is full of vinegar. Now, you also want to make sure that this discharge tube is elevated over the top of the lid so that you maintain a liquid head going into the cell. You don't want this line laying down to be able to drain vinegar out of the lines or out of the cell. So you want to be sure the cell will maintain full saturation of vinegar when it's in storage or when it's sitting. So we're going to turn the system on for 30 seconds and then turn it off. And the reason for running just 30 seconds is that the system will begin to monitor amperage after 45 seconds. So we don't want to reach that point. We want to turn it off before it hits 45 seconds. So our procedure is to turn it on and let it start running. And it's going to be pumping vinegar now out in this hose, going through the pump and into the cell to fill the cell up. And you let it run for 30 seconds. You can see the vinegar starting to flow through. There was also scale blocked in the tube. So you're looking for scale forming in the tubes or the fitting, and you really need to clean that scale. So I'm going to turn this off. It's 30 seconds. Okay. You let it sit for a minute. Doesn't take much. Make sure that the scale that's in there, you can squeeze the tube to try to break it up. And that scale is going to get washed out. And so now you can go ahead and proceed to do the second 30-second turn on. Turn it on. We're going to let it run 30 seconds. You can see scale trying to go through here, coming out of the cell because acid is beginning to dissolve it. And it's going to come in and go into the vinegar tank. So we'll let it run 30 seconds. Make sure this tube is elevated so that it keeps liquid in it, keeps the cell full of liquid. Okay, 30 seconds. We turn it off. Now, we let this sit for an hour. And so after an hour, we're going to let it dissolve in here. It's going to dissolve the scale that's in the cell. And then after 1 hour, we will turn the system back on to bring fresh vinegar back into the cell after some of that early vinegar, the one in the current cycle, has sat in there for a long time. It'll be neutralized to some degree by reaction with the scale that's in the cell. So we want to let it sit for an hour now, and then we'll come back and turn the system on again for 30 seconds in order to get fresh vinegar in there. Then we're going to let it wait another hour afterward. Okay, so now we have waited 1 hour. Vinegar has been sitting in the cell. The hoses are high, so there's fluid in the cell, fully saturated in the cell. We waited an hour, and now we're going to turn it on again for 30 seconds only. And that will put fresh vinegar in the cell to get fresh reaction going on here. And we're going to let it sit another hour. So 30 seconds. Turn the system on. We wait 30 seconds. Time it out. You can see material coming in the tubing, discharge tubing, that's going into the vinegar tank. That's material that's dissolved in the cell. So we're getting fresh vinegar in there, and we're going to turn it off and let it sit another hour. Okay, we'll come back in an hour and finish it up, put it back together. Okay, so we have now cleaned it for 2 1-hour cycles, and now we're going to flush the system and get it ready for service again. So you take the tubes out of the vinegar bottle and you put them in a bottle of fresh water. You take the filter out and put it in the fresh water. So now we're going to run fresh water through the system to get the system clean. We're going to do that by flushing the system 3 times, 3 30-second cycles. So we start by turning the button on. We let it run for 30 seconds. It's pulling water into the system, flushing stuff out of the cell, and putting fresh water in the cell. It'll take 3 cycles to completely purge the system. So that's 30 seconds. Now you can wait, you can start right away and go back and do 30 more seconds. There's no wait between these 30-second cycles. You'll begin to see the water clearing up. It's a little bubble still in. Okay, that's the second cycle of 30. 30 seconds, the last cycle. You can start it right away again. This will be the last cycle, and we'll put the system back in service. The tube is clearing up, the discharge tube. There's no electrolysis going on during the first 30 seconds. Okay, 30 seconds is complete. Turn the system off. Now you can put the system back in service. So you have the discharge hose here. And remember, we have the fitting here that needs to go back on there. And again, check to make sure the ferrule fittings are still on there. And recall that the tubes have to be hanging over the top of the container, be elevated, so that we keep water in the system when it was flushing and when it was cleaning. Then we take the filter, take it and put it back in the brine tank. And the rupture disc hose assembly is set. The safe place to put it is back in the brine tank. In case it ruptures, you don't want water everywhere. So we'll just put it back in the brine tank. And so now the system is ready to start and run again. So you turn it back on, it'll go through its normal cycle and start up, and everything is back to operation. So the next video you will see is a picture of the cell that we open up, so you can see that we cleaned it. Okay, so now we have taken the cell apart to show you what a clean cell looks like after the acid washing procedure. So if you'll recall, there's a lot of scale forming in the discharge port at the top, and likewise on the cell electrodes at the top. So it's now clean, it's ready to go back together, and then put back in the system and run the system again. Okay, so an alternative to using vinegar as an acid for cleaning the cell, we can use hydrochloric acid. Now, first step is wear eye protection and wear rubber gloves. And do this in a well-ventilated area, because hydrochloric acid will liberate chlorine gas. So to demonstrate the difference between the strength of vinegar and the strength of hydrochloric acid, I'm going to put a little bit of vinegar on this piece of concrete. A concrete has got a lot of calcium in it, so it should react and see bubbles forming with the concrete. Now you'll notice that it's not very reactive, but it does react a little bit, but it's slow. It's not nearly as strong an acid as hydrochloric acid. Now, to demonstrate the power of hydrochloric acid, we'll put a little bit of that on that concrete. And you can see the reaction occurring. You can see the bubbles forming. Much more aggressive. Okay? So keep the container covered. We put a little bit of hydrochloric acid in this jar to demonstrate this, make it a little easier. But that will react with the calcium and dissolve it. You can dissolve concrete with hydrochloric acid. So, the steps for preparing hydrochloric acid is due to its strength, you want to dilute it down. And there's only one way to do that, and that's to add acid to water. Do not add water to an acid, a strong acid. So this is hydrochloric acid, just a typical variety. Hydrochloric acid is common everywhere. It's used to neutralize the pH in swimming pools. It's used to get rid of calcium carbonate scale in evaporative coolers, swamp coolers. Lots of different ways it's used. So what you do is you get some water in a container, and we're going to add some hydrochloric acid to it. Be careful again. You don't want to spill it. And you're mixing it about 50-50. That's enough. Put the cap on it. And now you have a diluted solution of hydrochloric acid. So now we do the same procedure. The hydrochloric acid, diluted hydrochloric acid made up. And we have the brine suction filter and the oxidant discharge tube both in the same bottle. You simply turn on the system and let it operate. But muriatic acid is much more aggressive than vinegar, and it will do a lot better job of cleaning the cell quicker. You can do it again with vinegar, but again, if you have access to hydrochloric acid and safety equipment, PPE, personal protective equipment, then muriatic acid works much more quickly. So after you've done the cycle 3 times and you're complete, now you're going to clean out the system of any acid. And we do that with just fresh water. So you take the brine suction strainer and you put it in the water, the fresh water. This time, so then you turn the power on and you let it run, and you're pulling fresh water through the system and flushing the cell of acid, and you do that 3 times. Make sure everything's purged out of the system.